Now, back to this study guide question 2. There's two parts to the question. One of them is asking for a temperature variation, what is the part per million variation? So that's where you have this directly 1 Celsius, 1 part per million, or 3 millibars, 1 part per million. The second question is where the effective temperature and pressure are acting at the same time, which is maybe a little more realistic. And in that case, you then have to look at the full derivative and calculate the coefficients and combine the two together. So if you were to take, for instance, this refractivity formula, and if I can just maybe go to the last exam and point out that formula, rather than trying to describe it in a way that no one will follow. So this is the October 2010, which is the most recent one that's on the CBEP's website. Okay, now, this is the list of formulas that you'll notice in the October, sorry. What are we doing here? Just a minute. Yeah, this is October 2010. Now, you'll notice here that there are, starting at the top of the screen, 4 equations. The first two use refractive index, that's the little n, sorry. The other two use a capital N. The capital N is referred to as refractivity. And that's where you take the refractive index, which is usually 1.30 and then some numbers, and simply shift it to a number that's easier to handle. Now, the two formulas here that you see with the delta capital N, they are telling us corrections in refractivity, so the units are parts per million. If you take the second one that has the 282.1 in it, and put in 12 degrees in the T and 1013.25 in the P and evaluate it, you get 0. That tells us that that particular formula then relates directly to the conditions of that question. So that's the design refractivity is 282.1. So if you were to take that equation and take the partials with respect to P and the partial with respect to T, then you can answer the two portions of that question. If you were to try to do it to the 294.5 version, that would only work at 0 Celsius because of the way it's the part on the right hand side after the minus sign is the same expression. So then when you're using this formula, the number that comes out is in parts per million. And you take that number and multiply it by the distance, and that gives you the correction to the display, which is assuming 12C and standard pressure. So is there anything else about that particular concept or question that you would like to have explained? Excuse me.
I have nothing, James. Okay. Well, the only other question I have is where is the study material? Can I find coordinate differentiating and observation differencing?
Okay, that's not this particular collection of topics. It's under 3, which is engineering surveying. And you will find the references listed there in the learning outcomes. So what I can do, maybe while I have this up, I can go through this particular exam and indicate to everyone what topic area collection each one of these questions is in. The first one is a flat traversing, which is to some extent this topic, but it's maybe more appropriate for underground surveying because the traversing that's done in tunneling and underground is usually very flat. It's a question of whether we use angles or azimuths. And the second one is definitely engineering surveying because it's dealing with repeated measurements and monitoring deformations. The third one, to some extent, would pertain to what we're doing now. And this goes back to what I said during the introductory comments about doing a coordinate survey. And this particular problem is discussed in the first reference, Blackhout, and the others from 1979, the Urban Surveying and Mapping. Basically, if you have a parcel and you've gone from, say, 2 pairs of coordinated monuments and coordinate the corners, and then somebody else comes in from another pair from some other direction, the coordinate values won't necessarily coincide. In fact, they probably won't. And the question is, well, what causes that miscoincidence of the values? Part of it is in the uncertainty of the connections that are done by the 2 independent surveys. But on top of that is also the uncertainty between the coordinated survey markers themselves. And unfortunately, very often, we don't really know what that uncertainty is. And so in some provinces, for instance, they have very large margins of compatibility where if you go into an area and resurvey it and come up with different coordinate values within a very large amount, you say that you've really found the same points in the same positions and you use the older coordinate values. Because the coordinated monuments were probably coordinated several decades ago using much less refined methods. That's basically answering 3A. Now, what I was hoping for, what was expected in that second part of the question, was for you to relate to your own experience. If you've gone in and coordinated parcel corners and made a comparison, what sort of variation is allowed, and how do you use statistical testing to decide that? Question 4 is basically the second instrumentation testing and utilization topic areas. So we'll be dealing with that during our next session. And similarly with question 5. And that's the exam.